Good morning. If it's morning where you are, good morning. If it's in the afternoon where you are, good afternoon. And if it's in the evening or night, good night to you all. Bye-bye. No, I'm just kidding. Hope you're all well. This is Mr. Sampson. We're going to go through this. This is the Chapter 2 practice test, 1 through 20. This is going to be a longer video, but this is to help you understand what they're asking you for so that you can then do the actual real test, Chapter 2 test for real, because they are very, very similar. So if you can do the practice test, you can do the real test. We're going to get going through here. If you need to, you can skip ahead in the video to wherever you like. If you don't need number 1, skip it, go to number 2. Okay, I don't care. It's a video. You can go backwards and forwards as much as you want. Okay? All right. But it will take a while to go through these. I'll go through them as quickly as I can. Appreciate your patience and try not to be too bored. Shout out to my first period class and to my second period class. Josiah, you come to mind right now. So, hope you're doing well, all of you. All right, here we go. Number 1, drag and drop. Which one of these is a translation? Now remember, translation is going to be where it just slides, okay? So the shape size does not change, okay? It just slides. So if you look, let's see right here. This one right here, this one is a translation because all I did was slide the red, move it over to the blue. So this one is a translation. That goes there. This one right here, I'll go in blue. This one right here, that is not a translation. That is they may have slid it. They may have translated it, but they dilated it as well. And that is not okay. So that one is not a translation. All right, let's go to this one. This one is not a translation because they flipped it. It's the same size, but it's been reflected. So this has been reflected. Reflect. Okay, so that one goes to not. And this one right here, down at the bottom, I'll change it to gray. This one right here has just been slid. From red to blue, all they did was slide it up. So that one goes up there. All right, there's number 1. Number 2, translate the triangle 4 units to the right and 2 units down. All right, we're going to go 4 units to the right and 2 units down. So if you think about it, this is going to go 4, each one of these. Ooh, I like that. That's cool. But I don't like the thing. There we go. Let's go pink. Okay. You're going to go 4 units to the right. Okay. And then 2 units down. Right. And it's going to go right there. So your new point should go right there. Right. For that point back there. That's a terrible point. Sorry about that. So it should go right there. Right. Well, you're going to do the same thing. Right. There's a little arrow to help you. You're going to do the same thing. And I'm going to copy and paste this. Nope, not there. Copy and paste this. You're going to do the same thing for all the other points. See if it'll work. Okay, let's line it up. So that goes there. Ah, new point. Okay. And let's paste it one more time. Line it up. And that goes going to go there. Okay. So when you do that, let's do it in blue. You get new points. Point, point, point. All right, you get your new thing. So that's what you're going to do on Big Ideas. So you need to track your points here. Your point right here is 5, 1, your new point, right? This point right here is 5, negative 1. Negative 1. And this point right here, put a parentheses on them all. This point right here is a 0, 0, negative 1. Okay? So that's how you do it. Pretty simple. All right, reflections. All reflections. Feel like I'm looking in a mirror. Okay, let's see if these are reflections. First one, is it reflected? Is the red reflected to the blue? Okay, I believe so, because if you look, this little corner right there is closest, and this corner is closest, so that's definitely a reflection. Okay, so this right here is going to be, yes, it's a reflection. Okay. Next one. Is that a reflection? No, because if it was a reflection, we're going from red to blue, remember? It would be like right there, and then it would go like that and like that, right? That's not a reflection. Okay, so that doesn't work. So that goes there. All right, this one, is this a reflection? Well, look at this. You've got the shortest line of the parallel sides. You've got two sides that are parallel. And the shortest side is closest to the axis, right? Axis. But when you flip it, it should have had the shorter line right here and then the bigger one up here. And it's not. So that, it should have looked like this, pretty much. Can you picture that? Okay, so that is a knot. Not. Okay, and then last one, did they reflect it? Well, this corner is closest to this corner, right? And this one's further away, and this one's further away. So yes, this one's a yes. This is a reflection. Yes. Okay? All right, number 4. Drag and drop. We're talking about rotations now. Is it a rotation? Remember, rotations move the whole thing. They rotate usually around the origin. Let's take a look. All right. This one, we're going from red, remember? I'm going to do this quickly. If I had rotated this one, it would not be standing up. Right now it's laying down. If I had rotated it to this quadrant, it would be actually standing up like that, okay? Not the same. So that is a no. That's a no. I'm just going to write no on it. Not a reflection. Not this one. I mean, not rotation. This one, is it a rotation? Well, if we did it, right? I know it's not great. Oh, look at that. Man, it did it for me. That's crazy. I didn't realize it would do that. That's awesome. All right, if I reflected this, right, it would have been like that, right? Not the same. Not a reflection, okay? So that is not, okay? Not. Snot. All right, is this one a reflection? Well, we're going from here to here to here to here. Let's see if it'll do it again. No, it did a rectangle. Dang it. I wanted to see it. It does triangles and rectangles. It doesn't do trapezoids. We don't do trapezoids, Mr. Sampson. We only do triangles and rectangles. All right, so let me draw this thing in red. All right, if I reflect it, it looks like it's reflected on the x-axis. If I, not reflect it, if I rotate it, right, 180 degrees, which is the same as actually a reflection, you get it, right? Because the longer side is closer to the x-axis. So that is a yes. Yes, yes, yes. And last one, is this a rotation? We're going to go from here, 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 and here. I know it's not perfect, just go with it. Okay, so is this a rotation? Well, yeah, either way you go. This, if you rotate it, it's going to go there. And then if you rotate it again, it's going to go there, and it lines up. Okay, so that is a yes. Yes. All right, there's number 4. So if you want to look back, there's your answers. Number 5, going down here. All right, I have drawn this figure in blue with a red tail. They want us to rotate it clockwise 90 degrees, okay? So here's what I'm going to do. I'm going to take it. I'm going to rotate it 90 degrees. So that red tail needs to be, at the end, the red tail needs to be like that, right there. Does that make sense? So here we go. Nope, go back. All right, here we go. Rotate it right there. No, close enough, but it should be like right there. Right there, perfect. All right, so that's what it should look like when you rotate it. Now, you need the new points, right? You need the points for here. You need this point, you need this point, and you need this point. I'm not going to do it for you. You can find those 3 points and put them in, okay? That's what it should look like, okay? Zoom in one more time. Number 5, okay? Notice that this side right here is 3. That's the side that was right here. And this side right here, in yellow, is the longer side right here. It got flipped down. And this side right here, this is the hypotenuse. It's called the hypotenuse. Hypotenuse is this one. Those are the colors that are lined up just to help you Hope that helps you visualize it a little bit better. Number 6, I've already drawn the red triangle, traced it. The red figure is congruent to the blue figure. That's good. Which choice describes a sequence of transformations in which the blue figure is the image of the red figure? So how did we go from the red to the blue? And you've got A, B, C, and D, right? If we did this one in class, I believe, but we'll go through this, okay? All right. A, rotate the triangle 90 degrees counterclockwise about the origin, then translate it 10 units left and 9 units right. All right, we're going to go counterclockwise and 10 left and 9 units down. Sorry, down. Left and down. Well, look it. If I reflect this, right? I mean, if I rotate it 90 degrees, right? That's going to go right. Hold on, I'm almost there. It's going to go right there. Right there, almost. Just about right there. Move it up. Okay, good enough. It'll go right there if I rotate it 90 degrees, right? Well, if I move it to the left 10 units, that's going to be way over here. It's going to be like way over here, okay? That's not going to work, okay? So that is out. Now, since it said do it counterclockwise, and it took me a while, I'm going to look at C, okay? Because C says counterclockwise, okay? So we move it counterclockwise, like we did, and then it says counterclockwise about the origin, then translate it 1 unit up. Well, we could move it 1 unit up, no problem. Move it 1 unit up. If I move it 1 unit up, it goes like that. Well, it completes the other triangle and makes a beautiful square, but that's not what we're looking for. That doesn't make a blue figure, right? If I fill this in with blue, right? It's supposed to match up, not be on the opposite side, not be a reflection, okay? So that's not going to work. So we know that A is out and C is out. Now what we're going to do is we're going to take this thing back, okay? So I'm going to take it back, 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 and we're there back at the beginning. Now, it says, we're going to go with B. Rotate the triangle 90 degrees clockwise about the origin, then translate it 10 units left and 9 units down. Let's find out. All right, so we're going to take this thing, start back at the beginning. We're going to rotate it. Right now, this point right here is, it traced it. That point right there is -3, 3. So it should be over here when we trace it, when we reflect it. I'm sorry, when we rotate it, when we rotate it, should be at 3, 3, right? There, close enough. We'll get it. 3, 3. There we go. There we go. Now we got it. It's at 3, 3. That's rotated 90 degrees. Close enough. Okay. Let me just line it up a little bit better. There, much better. Okay. No, you moved on me. Okay, so we got it good enough. And then it says translate it 10 units left and 9 units down. That's going to be simpler. Okay, that's going to be easier. So here we go. I'm going to move it 10 units left. Now, you want to go from the origin. So you want to go from... If I zoom in, you want to go from right here. Just move the origin, because everything else will go with it, right? All the other points will go with it. Okay, so if I do this, we're going to move it 10 to the left. Okay? All right, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the left. And then 9 units down. Let's find out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Uh-oh, look at that. What happens? It works. It matches up. We got it. Okay? So the answer's gonna be B. Right here. Okay? It's not gonna be D. All right, so that's number 6. Number 7, you have 2 triangles. What's it says find the ratio red to blue. Remember, we're going red to blue. Okay? Red to blue. Find the ratio, red to blue, of the perimeters of the similar triangles. Write your answer. This one's actually pretty easy. What is the side right here? That is 5. What is the side right here? That is 9. Well, the ratio of the sides, right? The ratio of the perimeter, the ratio of the perimeters of the sides is the same. So if this is 5 to 9, then this down here is going to be 5 to 9. 5 to 9. That's it. Now, if it was area is always squared, so you'd have to you'd have to square those two numbers, but you don't because this is perimeter. All right, dilations. Which one's a dilation? If it's going to be dilation, one of them is going to be smaller and one of them is going to be bigger because they took the red and made it bigger, or they took the red and made it smaller. All right, look at the first one right here. That is not, because that's just a translation. They just slid it. They're both the same size, so that's not. Okay, we'll just put not and take off the arrow. All right, let's go look at the next one. I'm going to pick a different color. How about purple? Purple. How about this one? Is that a dilation? Did they take the red and make it bigger or smaller? Yes, they did. The blue is bigger. So that is a dilation right there. Okay? All right, how about the next one? Nope, they're the same size. That's out. That's not, because they're the same size. They're not a different size. And then this one right here, let's go back to gray. Look at it. Yeah, you went from red to blue. That's smaller, but it is a dilation, so that's a yes. That's a dilation. That does go up there. All right. We're making our way. We're at number 9 already. Number 9. Graph the image of the triangle after a dilation with respect to the origin using a scale factor of 2. Scale factor of 2. Okay, that means we double it. So everything here gets doubled, followed by a translation of 2 units right. We'll do that at the end. So here's the deal. Everything here, every point here gets doubled. So let's track the points here. This point is 0, 1, 0. This point right here is 0, 3. And this point right here is -5, 1. Okay? Well, all of those points, every x and y value, get multiplied by 2 because we're doubling it. We're multiplying a factor of 2. So this one, this new point, the new point should be everything times 2. Everything times 2 times 2. So it's going to be -5 times 2 is -10. 1 times 2 is 2. So there's going to be your new point. 0 times 2 is still 0. 1 times 2 is 2. So you get 0, 2. And up here, 0 times 2 is 0, and 3 times 2 is 6. All right, so we got our new points. Let's track them. All right, here we go. -10 is going to be way out here. -10, 2. I'm going to do it in red. -10, 2 is going to be right there. Okay. I'm going to see if it'll do the triangle trick again for me. If my notability will do it. 0, 2 is right there. Okay. It got moved up. And 0, 6 is right there. Okay. Now, let's see if it'll work. Let's see if I can track it, and track it. Let's see if it works. Bam! It worked. Ha ha! Hot diggity dog. And that's what it should look like. Okay? So you have your new points, right? I'm going to get rid of these. You have your new points right here. Those are your new points. And that's how you would just draw it on big ideas, okay? Maybe even be more perfect than mine, which is hard to do because I'm perfect already. Hope you're still with me. Hope you're doing well. This is number 10 on the practice test. All right. The red figure, let's see if I can get it to fit. The red figure is similar to the blue figure, or they're similar. Similar, that means they're the same shape, but not the same size. Which choice describes a sequence of transformations in which the blue figure is the image of the red figure? All right. Oh, wait. I'm sorry. I just forgot. My goodness, I forgot. Go back to number 9. We forgot. You got to do a translation. You got to do a translation 2 units to the right. So we got to take this thing and move it 2 units to the right. So I'm going to get rid of these points now because they'll be in the way. And get rid of these points. I'm sorry about that. I apologize. Forgot about the last thing. So I'm going to take this and move it 2 units to the right. Okay, so here we go. 1, 2. And there we have it. 1, 2. Buckle my shoe. All right, and there's your new points. So you want to have the new points right there. Now we go to number 10. Sorry about that. The translation threw me off. Which choice describes a sequence of transformations in which the blue figure is the image of the red figure? Okay, so we got to go figure out, like, okay, which one of these it works, right? And the thing is, guys, I know you could, like, just try the first one, try the second one, try the third one. There's actually more than one. But that's not going to help you on the test, because you can't guess on the test, and you can't, like, use check answers a million times on the test, right? So I'm trying to explain this one too. So this is number 10. Number 10. Hold on, let me write that in. Number 10, okay? How am I going from the red to the blue? Well, obviously it's getting bigger, yes? The red is smaller than the blue, right? The blue is bigger, okay? So we know we're translating it. You know you're translating it, at least translating it by a scale of, like, look, what are the sides? This side is 2, and this side right here is 4. So that sounds like a double to me. This side is 1, 2, 3, and this side is 6. So this is 6, this is 4, this is 3, this is 2. You can see they're doubling everything. So you know you're going to have a dilation of 2. So let's go look at here. All right, here we go. Dilate the triangle with respect to the origin using a factor of 2. Oh, that's good. That's a good sign, right? Then translate it 1 unit down and 10 units to the right, okay? Well, let's look at the other ones just real quick. The other one, dilate. So look at the next one. Next one. Dilate the triangle with respect to the origin using a scale factor of 1/2. Well, if you multiply it by 1/2, it's not going to get bigger like it did. It's going to get smaller. That one doesn't work. You can get rid of it now, right? And if you do see another one that has a dilation of 1/2, I do, right? Right here, 1/2. If you multiply by 1/2, it's going to get smaller, not bigger. So that's out, right? So you know you're down to two answers already. Okay, we know it's a dilation with a scale factor of 2 around the origin. Now, which one of these is going to work, right? So is it translated 1 unit up and 10 units to the right? We're looking at the first one. Is it, do we translate it 1 unit down and 10 to the right? Well, 1 unit down, like, let me just, if we go, let me draw this. Let me get rid of the things. Okay, if we just, I know we haven't dilated this yet, but I'll do it quickly, okay? I'm going to dilate it to where it's twice as big. It's going to be like that. Okay? All right. Now, wherever we are, right, if we're there, with respect to the origin, wherever we are, if we take this thing and we go 1 unit down and then 10 units to the right, is it going to work? Look at it. All right, I'm going to take it 1 unit down and then 10 units to the right. It's going to go that way. It's going the wrong way. Come back. Come back. Come back. Come back. Okay, that's not going to work. All right, come on back. So we know this one's out. Okay, it's not going to go 10 units to the right. This one's already out. This one's out already. So I'm guessing it's this one right here. Let's track it, though, just to make sure. Dilate it by 2, right? Scale factor 2. Then translate it 2 units up and 10 units to the left. All right, 2 units up. Oh, sorry. Hold on, go back. 2 units up. 1, 2. Oh, it's already going to go up 1. It's already going to be like this. It's, I'm sorry, I forgot to do this correctly. Go back. All right, so this one is already going to be right there. I'm sorry to double, because this point doubles. This is 1, 1, right? This is the point, this is the point 1, 1. Well, if it doubles, it's going to be the point 2, 2, which was right there, okay? So now we've got it right. Now we've got it in the right place, okay? We got it in the right place. Now we go up 2 units like it says. Try it. 2 units up. 1, 2, and 10 units to the left. Let's find out. Going 10 units to the left. So we're right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it 9 or 10? I think it lines up. 10 units to the left. Yeah, we get it. So your answer is right here. How could you have done this, right? You could have tracked the points, right? So if we go back, we were right here, right? We moved up 2, right? And then you take this point, like let's say this point right here. This point is now, this point right here is 1, 4, right? Well, if we're going to go to the left 10 spots, right, we're going to go 4 minus 10, which would be -6. And the 1 is still the same, so it should be 1, -6. Does that line up over here? Where am I? 1, 4. Where am I going? 10 units left. I'm missing something. Anyway, we know that it's this one by process of elimination. We know it's this one, okay? Now, if you'd like, I have the actual answers on another page. I can actually go check there, okay? Let me go there. Number 10. We'll get to 13 in a second. Number 10. Yep, we were right. It's that one, okay? We know it's right. All right. You guys are being patient. I know this video is long. Thank you for your patience. All right. Which translation moves the entire figure into the second quadrant? There's more than one, I think. All right. I've traced it already. How do I move this? Let's go option by option. Add 2 and add 2. Right now, let me just clarify here. Right now, this is the first quadrant. This is the second quadrant. It's always like this. This is the third quadrant. And this is the fourth quadrant, okay? Well, to move it to the second quadrant, it's got to go up, right? It's got to go up and go to the, now watch what happens. All right, if I go up, if I translate it, it's going to go 2 up and 2 to the right, right? Do you see this? This is going to the right, and this is going up. Does that make sense? So let's go to the right first. And up, let's go to the right 2, and then go up 2. So go to the right 2, and then go up 2. Right there. Go up 2, right there. Well, that's not, I mean, part of it's in the second quadrant. I mean, but part of it's not. Okay, so I'm not sure if that's the right one. So we're gonna wait on that. I don't think it is. So let's. Oh, and this goes to the right 2. This goes up 2. This goes left 4, and this goes up 6. Let's go see if that works. So let's go back to the original beginning here. Okay. Let's go right here. Now it says, let me go back. Left 4, right 6. Left 4, right 6. So we're going to go left 4. Sorry, left 4. 1, 2, 3, 4. And up 6. 1, 2, 3, 4, 5, 6. Yes, that for sure works. You're now in quadrant 2. Okay, so this one for sure is a winner chicken dinner. Okay, however, there could be more. So we got to go back. Okay, let's take it back and do the third one. This one, you're gonna go to the right 5 and up 6. Okay, so let's go to the right 5. Well, that's not going to work at all. Look, if you go to the right 5, go to the right 5. 1, 2, 3, 4, 5, right about there. Okay, and then up 6, that's going to be in the other quadrant up there. That's not going to work. Okay, let's just take that back. That's not going to work. So that one, so this one is out. This one is out. Let's try the last one. This tells me that I'm going to go left 4 and up 1. It's possible. Okay, it's possible. So let's go look. Left 4, up 1. Left 4, 1, 2, 3, 4, and up 1. No, that's not, it's still in the third quadrant. Not going to work. Okay, so that one is out as well. Out. So, I mean, we can go check it, but number 11, but I'll bet you it's just that one. Yep. Yep, that's what we got. We got the same answer. I'm on the right path. All right. Number 12. Number 12. Which reflections reflect a point A negative A onto A. Select and apply. What does that mean? A negative A and AA. So I want you to think of like just a number, right? Let's say this was 2 and negative 2, okay? Where would that be? Where would that point be on the graph? Well, I'm going to go back up and use the graph here, okay? And where would A, this, if that's true, if we're using 2 for A, this would be 2, comma 2, right? All right, let me go show you right here. 2, negative 2. Let me get rid of all this now. Let me clear this page. Yeah, I can clear the page. Let me clear all this. 2, and you don't need all this, okay? But 2, negative 2 is right. 2, negative 2 is right here. So that is in quadrant 4, okay? That red point right there is in quadrant 4. And 2 is up here, right? That's in quadrant 1. Does that make sense? So this is quadrant 4, and this is quadrant 1, right? Okay, so now we kind of get a picture of where it's at, right? So this is in quadrant 4, like we said, and this is in quadrant 1. All right, well, what did we do? It got either slid up or it got reflected. All right, so let's look. To get from the first one to the second one, like we did, okay, would you reflect it on the y-axis? Let's go back up and look. Would you take this point right here? Is that reflecting on the y-axis? Is this going like that on the y-axis? No, it's doing the x-axis. So that one's out. So it's not y-axis. It's actually the x-axis right here. You can see the x-axis is right here. It's reflecting on the x-axis. Okay, so let's go down here. So we know that this one is out. That's not it. We know that this one is in. That's true. All right, now it gets a little tricky. So let's do this. Reflection. Okay, are you going to reflect it in the line y equals x? So you switch it. You switch the points, and then reflection in the y-axis. So let's go find out. Okay, so here's what we got. Right now, this is the x value, and this is the y value. Okay. So it's saying x equals y, right? So it says y equals x. So what they're saying is make this, like, flip them. So this would actually be negative 2, positive 2. Does that make sense? You're equaling each other. So you flip them. And then reflection on the y-axis. So I think I think it's going to work. Negative 2, 2, and then you flip it on the y-axis. You reflect it on the y-axis. So let's go do this. Negative 2, 2. So you take negative 2, 2. Negative 2, 2 is right here, right? And then reflect it on the y-axis this way. Let me get rid of the old stuff, right? If you reflect it on the y-axis, it does work. It gets to the same point, okay, on the y-axis. So I believe that's correct. And that means the other one's not going to be correct. Okay, so I believe this is right. And then if you're not going to do the same thing and get on the x-axis, that's going to be out. So I think it's those two answers. Now, we can go check. I've been wrong before. Nope, I'm right. Okay, so we were absolutely right. Okay. All right, number 13. All right, I've looked at this one. It says, and it was a little confusing. I had to think for a minute to figure it out. So here we go. A figure has rotational symmetry. If a rotation is 180 degrees or less, produces an image that fits exactly on the original figure. Select each degree of rotation that shows the figure below has rotational symmetry. So here's what you have to know before you get started. you have to know how many slices of this pie are there, right? There are 6. Do you see this? 1, 2, 3, 4, 5, 6. There are 6. Well, you also need to know how many degrees are in a circle. Well, there's 360 degrees, right? So what you're going to do here, what you're trying to find is you're trying to find what is each of these, right? What is each of these? This and this and this and this. What are all the degrees of each slice of the pie? So what you're going to do is you're going to take 360 divided by 6. Remember this one for the test, because on the test, I'll help you out. There's not 6 slices, there's 8. I hope you're listening. Not 6 slices, there's 8. Now, anyway, let's go back to this problem. You're going to take 360 divided by 6. Well, that's going to give you 60. So all the things of 60, all the degrees of 60, right, that have 60 in them, right, that has 60 as a factor, will work. So we're going to start with 60, okay? 60 works. 90 does not, 45 does not, 30 does not. 60, count by 6s, like count by 60s. 60, what's the next one? 120, right? And what's the next one? 180. So it's 60, 120, and 180 because it's all by 60. It's all in 60s, okay? So these are out, 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 okay? Remember that for the test, because you're not going to divide by 6 and get 60. You're going to divide by 8, because on the test, it's going to have one that has 8, not 6 little things in the middle, okay? Just remember that. Remember the 8 for the test. Okay, all right, number 14. The vertices are right here. They make a triangle. Which of the following describes a transformation in which the coordinates are multiplied by 3 over 2? Well, here's the deal. What is 3 over 2, right? Is 3 over 2 a fraction? Yes. But is it an improper fraction? Yes. If I divided 3 over 2, right, this becomes 1 1/2, yes? Well, 1 1/2 is bigger than 1, yes? It's bigger. It's not smaller than 1. It's not a fraction. It's a number with a fraction. It's bigger. What is it bigger when it's called a enlargement, reduction, translation, or rotation? No, it's just an enlargement. So if you multiply something by 3 over 2, it's going to get bigger. It's going to be an enlargement. All right, that's number 14. Stay with me. Now, number 15 is long. Stick with me. We'll go through this. All right. Consider a coordinate plane. Okay. Consider a figure on a coordinate plane. We can do like a triangle if we needed to. For each of the transformations below, first transform the figure as stated. Then reverse the order of the sentences and transform the original figure a second time. Okay. Did the sequence result in the same image or different image? Drag and drop each transformation in the cell with the appropriate heading. Okay, so what we need to do is I'm going to go back up to one of the graphs. And I'm going to draw just a triangle, okay? Doesn't give me any specifications on, but what we're going to do is we're going to do the first thing. We're going to dilate with respect to the scale factor of 3. Then we're going to rotate it 90 degrees clockwise and see if it works. It should technically work if you go backwards. So here we go. We're going to draw a triangle, dilate it with the scale factor of 3, and then rotate it 90 degrees clockwise. Okay, here we go. Let's go back up to our graph. I need a graph. Anybody have a graph? I got one. Okay, okay, here we go. Actually, matter of fact, we've got a triangle already. Okay, so let's take these points, let's dilate it with a factor of 3. Okay, so this point right here is -1, -1. It'll work, okay? This point right here is -1, -5. And this point right here is -4, -1, okay? We're going to take everything and multiply it by 3, okay? 3. That's going to give me -3, -3 right here. That's going to give me, and I'll move that out to the side, okay? Move it up here. This one is going to give me -3, negative 15. That's going to be big. Okay, it's going to go right there. Let's move that out. And the last one is going to give me negative 12. Negative 4 times 3 is negative 12. Negative 3. And we'll move that one up here. And then we'll track the points. Now, it's probably not going to fit. No, it won't fit. But that's okay. We'll just go with it. Okay? So, negative 12, 3. I'm going to kind of just, negative 12, negative 3 is going to be out here, right? Negative 12, negative 3. We're going to continue this line right here, okay? Negative 12, negative 3. It's going to be down here, actually. Okay, negative 12, negative 3. Let's go blue. Okay, is going to be right about here. Okay. And then negative 3, negative 15. Negative 3, negative 15 is going to be down here. Right about down here. And then negative 3 is going to be right there. Okay. Connect the dots, make a triangle. Okay. Connect the dots, make a triangle. Oh, that's terrible. But for our purposes, it'll work. Okay, so you've got this big dilation, okay? What did it say to do? It said to rotate it 90 degrees clockwise about the origin, right? Do you get the same image? Wait, oh, hold on. Do you get the same image? Looking at the first one. Dilate it 1/2. I'm guessing no, because you're not going to get the same image because you dilated it. So we don't need to, okay, so I'm going to guess that this one, if you dilate it and make it 3 times bigger and then rotate it, it's not going to be the same image. It's going to be a different image. Okay, so this one's got to be out. Dilate it. Yeah, dilate it 1/2 and then translate it to, okay, so we don't have to make this as hard as we're making it. Think about it. If you dilate it, it's going to be a different size. Okay? If it's a different size, right, it's going to have a different, it's going to not be the same image, right? Because this one, you're making it 1/2 as big, right? So that one's going to be out. And then rotate it 90 degrees clockwise about the origin, then translate it 4 units up and to the right. It's possible. Okay, we could do that one. And then dilate it with a scale, and then dilate it with respect to the origin using a scale factor of 1/3. I don't think that's going to be right. So here's what we're going to do. For the sake of time, let's go look at number, this one's a tough one. All right, correct answers. Oh, the correct answers were, sorry about that, number 1 and number 2. Okay, dilate it, and then dilate it with respect to the origin with a factor of 2, and dilate it, then dilate with respect to the origin using a scale factor of 1/3. Oh, okay. So the correct answers for 1 and 2. Okay. This one is tough. I may have to do another separate video for just number 15. Okay, so there's your answers for the practice test. You're going to drag and drop. And I'll come back to this one and we'll look at it. I may have to do a separate video for just number 15 once I figure it all out. Okay, let's go back. Let's go to number 16. So what did we say? The answer was factor of 30. I believe this one goes here. And this one, I can't remember. We'll check it later. Number 16. This one's actually pretty easy. The pentagons shown below are congruent. The length of the side LM is what? So if you look, this side right here is the same side because everything else matches up as right here. Well, this one is 40. This one's going to be also 40. That's simple. Okay. All right. Number 17. The coordinate grid shows the location of the treasure at X. Okay, you are located at O, way down here. Okay, order the transformation below so that you can that they lead you to the treasure. So you've got to go from here, right here, all the way over there, right? But you can't just go straight, right? You've got to like move around and transform and all of that, okay? Okay, so we're going to try one thing at a time. So let's start. I want to start with translating. Because that's pretty simple, okay? And this is green, okay? So we'll just have our green dot right here, okay? We're going to translate 1 unit to the right. So I'm going to move this dot, and let me zoom in. Move it 1 unit to the right, okay? And then let's try reflecting it on the x-axis, okay? So let's see, reflect it on the x-axis. So that would be up here. So this is this point now is -4, -5. Well, if we reflect it on the x-axis, the y value becomes positive. So instead of -5 right here, it's going to be +5. So it'll be -4, +5 right there. Okay. Well, so far, and then what's the last step? Rotate it 90 degrees about the origin. So if I rotate it 90 degrees, it might actually work. So what is the point right here? It was -4 and 5. If I rotate it, it'll become over here, it'll become 5, 4, which is right there. I think that actually works. I think we figured it out. Okay, 5, 4. So here we go. Translate it. I think I got the steps. This is step number 1. Translate it 1 unit to the right. Number 2, reflect it. And then the third step is rotate it 3 steps. I think that's what it is. Let's go check. Okay, sound good? Let's go check. Reflect it. Oh, correct. Let me see. How to translate it 1 unit. 1, reflect it on the x-axis. Oh, okay. 2, translate it to the right one and then rotate it 90 degrees clockwise. All right, so let's do that again. All right, let's go back. Let's get rid of this. Okay, so it said reflect it on the x-axis. So if we reflect it on the x-axis, that green spot goes up to here. Okay, and it becomes a -5, 5. Okay, -5, +5. So there's reflect it on the x-axis. That's step 1. Step 2, translate it 1 unit to the right. That's going to go right there. 1 unit to the right. That's now going to be -4, 5. Okay, and then you reflect it. So -4, 5 becomes 5, 4. Because when you do it, when you rotate it, the x and the y switch, right? The x and the y values switch, and the -4 becomes a +4. So that's how you do it, okay? So it's 1, 2, 3. All right, we're almost there. Got 2 more. This one we did in class. I can draw it for you. How are we doing? Man, this is a long video. I know it's super long. Here we go. Stop. Okay, so I'm going to draw the guy. I want you to imagine you have the guy. He's 6 feet tall. Okay, and it's on the ground. You've got a light that's up here. Okay, here's your light. Double line, okay, and the light right there. And it casts a 15-foot shadow from the man. So I want you to imagine you've got this, you've got the shadow. The light shines and it goes down like this and makes a shadow, right? Okay, so we know that he's 2 similar figures are formed. One triangle is formed by the person and the shadow. The other one is formed, the second triangle is formed by the street light all the way to the ground. Okay, we know it's a 15-foot shadow, and we know that he's standing 15 feet from the light. So I know it doesn't look perfect, but here's what you need to see. This right here is 15. And this right here in red is also 15. I know it doesn't look like it because of my bad drawing. But that's 15 and that's 15. Can you see the two triangles, right? You've got the big triangle and then you've got the little triangle. The little triangle, I'm going to draw it in green. The little triangle goes right here. It's the guy and then this part right here. So you've got a small little triangle like that. And then you've got a big triangle like that, big one. Okay, well, the small triangle has a bottom of 15. The big triangle is going to be 15 and 15. So that's going to give you 30. So what's the scale factor, right? How many times bigger is the light than the person? Well, this side is 30 is twice as big as 15. So it would make sense that this is going to be twice as big, right? So it's going to be 2. It's 2 times bigger, taller. The answer is 2. All right, a rectangular shaped desk has a length of 25 inches and 18 inches. I'm going to draw that. So I've got a rectangle, 25 inches by 18 inches, okay? A desk with a similar length has 60 inches in length, so that's bigger, longer, and it's going to be taller, right? This is 60 inches in length. What's the width of the desk? What's X? You're looking for X, okay? Okay, so here's the deal. This is a ratio. We can find X, right? By going from 25 to 25 to 60 and then 18 to X, okay? So we're going to go 25 to 60. So let's write that down. I need some room here. All right. 25 to 60 equals little to big, 18 to X, okay? Well, here's the deal. Before we cross multiply and solve this thing, 25 and 60 will reduce, right? 25 and 60 will reduce. So 5 goes into 25 5 times, 5 goes into 60 12 times. That's going to make it a little bit easier. Now, we do have to take 12 times 18. 12 times 18 is 216. So when we multiply up, right, I get 216. I'm going to do it in black. 216. And then when we multiply up, I get 5x on this side. So it's going to give me 5x. So here's what we get. 5x equals 216. Okay, we got to divide by 5. Scale line, divide by 5. Divide by 5. Step line, right? 216 divided by 5 is going to give you a decimal. Come on. 216, I'm using my calculator, divided by 5. 200, come on. 216 divided by 5. 43, so x equals 43.2. That's going to be your answer. So that's how you do it. All right, and then lastly, here we go. We're on the last one. We're nearing the finish. Let me clear this out. A rectangular school banner has a 54-inch by 36-inch width and width. A sign is made that is similar to the school banner and has a length of 17 inches instead of 54. What is the ratio of the areas of the banner? Okay, ratio of the areas of the banner. Okay, so here's the deal. This is going to be ratio of the school banner. School banner is the first one. School banner to the what is the ratio of the school banner of the area of the sign to the sign? This is the sign, right? So it's got to be 54 to 17 because that's what they're giving you, 54 and 17. However, it says the ratio of the areas. Area is always squared, okay? So we're going to square this. We're going to square this and square this. You got to use your calculator. 54 times 54 is 2,916. 17 times 17 is 289, and that is your answer. I've checked it already earlier before I started this video. Guys, thank you for putting up with me. I know it's been a long video. It's like an hour long. Thank you. Appreciate your patience. I hope you have a great rest of the day. Use the practice test to help you on the test. And I hope you have a great rest of your day. Thanks. Take care.